Hi, this is Miss McClellan here to go over IM2 Notes 5.1.1 with you. How can I describe a parabola? Now we have two learning goals. The first is that, one, given a quadratic function, I will be able to construct a table of values and points I can use to graph my parabola. And two, that given the graph of a parabola, I will be able to identify and label all important features. And those include the x-intercepts, the y-intercepts, the line of symmetry, and the concavity, and the vertex. And we start with an example. So in a moment, I'll go through a poster activity that you would have done in class, and that's what this is talking about right here. But for now, I'm going to do an example function. So remember, our first learning goal was that we could make a table using a function. Well, here's a function, and I'm going to make a table. I'm going to pick some x values. I'll start with, -5. And then I plug that x value into my equation to find y. So I have negative of -5 squared plus 3 times -5 plus 4. Which gives me -25 minus 15 plus 4, and gosh, what is that? -36. So the point -5, comma, -36 would be on my graph, although that is outside the range of these values that I have on my coordinate plane. The next point, I'll do -4. That's negative of -4 squared plus 3 times -4 plus 4. So that's -16 minus 12 plus 4, which is -24, right? No. Yeah, it's -24. So the point -4, -24 should be on my parabola. Okay, let's do -3. Negative of -3 squared plus 3 times -3 plus 4 is -9 minus 9 plus 4, which is -14. We've got -3, -14. Okay, -2. Negative of -2 squared plus 3 times -2 plus 4 is Negative 4 minus 6 plus 4, that's negative 6. So the point negative 2, negative 6 should be on my graph. That one will fit. Okay, negative 1. Negative of negative 1 squared plus 3 times negative 1 plus 4 is negative 1 minus 3 plus 4. That's 0. So the point negative 1, 0 is on my graph. 0, negative of 0 squared plus 3 times 0 plus 4 is just 4. So the point 0, 4 is on my graph. 1, negative of 1 squared plus 3 times 1 plus 4 is negative 1 plus 7 is negative 6. So the point 1, negative 6 is on my graph. Okay. 2, negative of 2 squared plus 3 times 2 plus 4 is negative 4 plus 6 plus 4, that's 6. So the point 2 comma positive 6 is on my graph. I'm going to start plotting these. Okay, so I'll start from the bottom. Over 2 up 6. Over 2 up 6. This should be on my graph. Done that one. And then sorry, this previous one should have been positive 6. So 1, 6 is also on my graph, right? And at 0, I'll be at 4. So I've got these 2 points. At negative 1, I'm at 0. This point. Negative 2, I'm at negative 6. This point. Negative 3, I'm at negative 14. That kind of fits here-ish. All right, and then, you know what? I can't quite see the shape of my graph, so I'm going to do a few more points. At 3, I'm at negative of 3 squared plus 3 times 3 plus 4, which is negative 9 plus 9 plus 4. That's just 4. 3, 4. Oh, isn't that cool? I'm noticing that these two numbers have repeated, but in opposite direction. I wonder if that'll keep happening. Let's look at number 4. Negative of 4 squared plus 3 times 4 plus 4 is 0. So the point 4, 0 is on the graph. Let's add those points. I go over 3 up 4. I go from 0 over 4, 0. Okay. So I've plotted all of the points that I found. And what I am really noticing is that even though I haven't calculated any more points on this side, just based on how it looks like these are symmetric, like it's a mirror image, I think I can plot the next point. So I'm going to go here, over one more and down that much. Here we go. And then here, I'll go over one more and down that much. So let me make that a different color. This part I did with symmetry. And you might notice that I didn't connect the points up top. That's because I'm not sure if this should be straight across or arched up. And since I've got symmetry, I'm going to sort of figure it out by considering what the middle of this parabola is. So let me look. Da, 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 da. I need a line. Here we go. So if I were to draw a line straight down the middle of this, then I think that would be the line x equals 1.5. And I'm going to do just one more point with my table where I'm going to use that 1.5 value of x to get where that last point I want to draw is going to be. So let me put that in. 1.5 negative of that squared plus 3 times 1.5 minus 4. And I can't do that in my head, so I'm going to use a calculator. And when I plug that into my calculator, it comes out to 6.25. So the point 1.5 comma 6.25 is also on the graph. Let me try to get that right. Put it about right here. Just a little bit above. Try to make this look kind of curved. All right. So now we're going to describe the graph. What a description of a graph means is to label these important features. So this graph opens down. We call this concave down. And I like to write the N of the word down so that it looks like a parabola. That helps me remember. The vertex is going to be the highest point. So for us, this point right here is the vertex. And it is the point 1.5, comma 6.25. The x-intercepts are, based on inspection, located at -1, 0 and 4, 0. The y-intercept is located at 0, 4. Don't know why that's not working. The line of symmetry is that line that we drew right down the middle of the parabola, and it's x equals 1.5. So that's one example done out. And then in class, you would have taken all of these, each group gets one, and drawn the graph on a poster with your table. And then afterwards, we would have presentations where you took notes on the results of every single group's work. Since you're watching the video, I'm assuming you weren't necessarily in class, so I'll be doing those presentations right here. Before I do the presentations, I want to go over some math notes. This is math notes, 5.1.1 features of a parabola. Okay, definition of a quadratic function in standard form. A function is in standard form if it can be written as y equals ax squared plus bx plus c, where a, b, and c are constants and a does not equal 0. This is familiar to the form that you've been using to factor ever since chapter 4. The only difference is now that we have the y equals part, it becomes a function instead of just an expression. Vertex form. The vertex form of a quadratic function is y equals a x minus h squared plus k, where a does not equal 0 and hk is the vertex of a parabola. And this form will be covered in chapter 9. Now concavity. Concavity is the direction a parabola opens. So graphs that open ups are described as concave up, and those that open down are described as concave down. And you don't have to do those little arrows for your letters, but it helps me remember the difference between concave up and concave down. Now the line of symmetry. This is a vertical line passing through the vertex. It is often found by averaging the x-intercepts, but any symmetric points will do. So in the example we did on the first page, how did I find that this was 1.5? I think I did it just by looking between these 2 points and realizing it was at 1.5. But you could also have done -1 plus 4 from the x-intercepts divided by 2 equals 3/2, which is 1.5. Okay, whoopsie, too far. Another way that you can find the middle of a parabola is to use the formula x equals -b over 2a. When we start talking about the quadratic formula, this is a piece of it. Okay, and let's talk about the vertex. The vertex is the highest or lowest. Highest if you're opening down, lowest if you're concave up. Point on the graph of a parabola, and to find the vertex, first you determine the line of symmetry, and once the middle x value is found, you plug your vertex x value into your original equation, and solve for y. We did that up here. When we plugged 1.5 from the line of symmetry into the equation and got 6.25 for y. The coordinates of the vertex are then the x piece and the y piece. Now intercepts. Y-intercept. This is found by setting x equals 0 into the original equation. That's because when I'm on the y-axis, x is 0 for all points. And for an equation in standard form, the intercept is always just going to be that c value. So it would be x is 0 and y is c. X-intercepts. Now we're going to learn how to find x-intercepts in upcoming lessons. There are lots of methods. Parabolas can have 0, 1, or 2 x-intercepts. Okay, domain and range. We're not going to be listing the domain and range for all of these problems, but domain and range are important concepts, so they're included in these notes. Domain, all real numbers. For parabolas, x can take on any value. Range. When a is positive, the graph will open up, and the range will always be y is greater than or equal to the y-coordinate of the vertex, where yb is the y-coordinate of the vertex. Anyway, if a is negative, then y would be everything below that. Here we go. we're going to label the features for each of these problems. Y equals 1.5x squared minus 3x plus 2, and the graph is provided for us. Concavity, this is concave up. It opens up. X-intercepts, I don't see any. None. This parabola does not pass the x-axis. Y-intercept, right here at 0, 2, which it should be because 2 is C. Line of symmetry, let's draw a straight line down the middle of this parabola. That's at x equals 1, because these are counting by 2 on the x-axis. So x equals 1. Domain, all real numbers. And range. Well, this opens up, so all the possible y values are y is greater than or equal to 2. Up. 2. Sorry, not 2. This looks to be at about, this is 1, this is 0.5. Y is greater than or equal to 0.5. Okay, next. A new equation. This is concave down for the graph y equals negative 2x squared plus 6x minus 4.5. This is concave down. I see only one x-intercept. It's at, let's see, this is about 1, so that's 1.5. 1.5 comma 0. And for y-intercept, that's going to be at 0 comma negative 4.5. The line of symmetry, that cuts right down the middle. That's x equals 1.5. Domain, that's all real numbers. Range, that's y is less than or equal to 0, since the vertex is at 1.5 comma 0. And you know what? I forgot to put the vertex on the last one too. Add it right here. This vertex is at 1, 0.5. Last part. Okay. This equation is y equals x squared plus 6x. You might think, no C? No big deal. NBD, it's 0. If you like, you can write in plus 0 here, but you don't have to. Concavity, this is concave up. X-intercepts, I see one x-intercept at negative 6, 0, and the other is at 0, 0. Y-intercept, that's at 0, 0. Line of symmetry, what is that? Negative 1, negative 2, negative 3. That's x equals negative 3. Domain, that's all real numbers. All real numbers. Range, that's everything above negative 6, negative 7, negative 8, negative 9. Y is greater than or equal to negative 9. And we can't forget the vertex, which is negative 3, negative 9. Great. So now I will go ahead and do some of those presentations for you. Now, during the presentations, your classmates would have shown you a table of values. So I'm going to add a table of values for each of these. Got x and y. And I'll start x at -5 again, and then I'll throw that in my calculator to find out what y equals. And when x is -5, y is all the way up at 27. That's not going on a graph. What about when x is -4? Put that into my equation. Just to be clear, I'm doing -4 squared minus 2 times -4 minus 8 to figure out what goes for y. And we have y is 7. Sorry, not 7, 16. X is -3 gives us y is 7. X is -2 gives y is 0. X is -1 gives y is -5. X is 0 gives y is -8. X is 1 gives y is -9. X is 2 gives back -8, and then 3 should give back -5, etc. Okay, I'm going to plot the points that I can plot. This one I can't plot, it's too far away. Okay, -3, +7. -3, +7. This point should be on my graph. 0, -2. -2, 0. That's on my graph. -1, -5 is on my graph. Let's see. Okay, 0, -8. That seems fishy to me, but we're going with it. 1, 0. Pause over 1, down -9. And then the mirror points start happening. And I can connect these with a smooth curve. Always connect your graphs with smooth curves. I don't want to see any pointy graphs. Okay, so this is concave up. The line of symmetry is x equals 1, and I found that by inspecting visually where the middle of the graph is. The vertex appears to be at -1, -9. Again, I used visual inspection. The x-intercepts appear to be at -2, 0, and 4, 0. That's visual inspection again. So that's, let's see, the y-intercept would have been right here, which is -1, -8. Okay. Next problem. Y equals -x squared plus 4. Okay, we'll make a table. X, y. I'll start at -3 this time. -3. So that's negative 9 plus 4 is negative 5. Negative 2, that's 0. Negative 1, that's 3. 0, that gives me 4. 1 gives me, what does 1 give me? 3. 2 gives me 0. 3 gives me 5. Okay, let's plot it. At negative 3, when x is negative 3, y is negative 5. When x is negative 2, y is 0. When x is negative 1, y is at positive 3. When x is 0, y is positive 4. I've got here, I've got here, and I've got here. Okay, smooth curve. I'm making very careful to make sure I don't have a pointy graph. Let me make that clear. So, no. Yes. This is a curved graph. Okay. Anyway, this is concave down. The line of symmetry is at x equals 0. The vertex is at 0, 4. The x-intercepts are 2, 0, and negative 2, 0. And the y-intercept is at 0, 4. And for all of these, I did visual inspection. Next. Okay. X and y. I'm going to start at negative 5. And let me just think. So plugging that into my calculator, I get when x is negative 5, y is positive 40. I'm not going to find that to be useful. Let me skip a couple. Let me go down to x is 2. What happens when x is 2? Negative 2. Okay, well, when plugging that in, I get 7. That's more graphable. Okay, negative 1. That gives me y is 0. Really? Let me think. 1 minus 1 plus 4. I had some calculation errors in my previous pieces. This should have been at 50. This should have been at 12. Okay, when x is negative 1, y is 10. Sorry, this last one shouldn't have been 12. It should have been 17. Yikes. Okay, anyway, those are all of my mistakes. No more. When x is negative 1, y is 10. When x is 0, y is positive 5. When x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 5 again. And then I repeat. I go up again. So from 5 to 10, etc. Let's plot this. Negative 550 is not going to make it on a graph. Negative 217 is not going to make it on a graph, but negative 110 will. So that's right here. 0, 5 right here. 1, 2 right here. 2, 1 right here. 3, 5. Sorry, it should have been 3, 2. And then 4, 5. 3, 2, 4, 5. The reason I knew I made a mistake was because I was ending up with a graph that wasn't going to be symmetric. Anytime you have a graph that is a parabola, If you're drawing it and it's not symmetric, you made a mistake. Okay, because this is concave up, the line of symmetry is at x equals 2. That's right in the middle. That's how I knew. Line x equals 2. The vertex is at 2, 1. That's the point right here. And I don't pass the x-intercept, and that's fine. There are no x-intercepts. And my y-intercept is at 0, 5. And it should be because 5 is the c value for my equation. All of these I found by inspection. Visual, inspection. Okay, next problem. Let's see. Make my little t-chart, x and y. I plug that in and I get 6.25. So my vertex is going to be at 1.5, 6.25. That means this point right here is at 1.5, 6.25. My x-intercepts are at -1, 0, and 4, 0. My y-intercept is at 4, 0. And let's see, how did I find my line of symmetry? I averaged 2 symmetric points. I could be more specific. I averaged the x coordinates of. And the vertex, I plugged in the line of symmetry, x value, into my original equation. And the intercepts I found by visual inspection. This is probably the most important example we've done so far because of this piece. Okay, next. Y is -x squared plus 2x minus 1. I'll make my table. Okay, I'll start again with x is -2. I plug that into my equation, y is -4. -1. I plug that into my equation, y is 0. X is 0, I plug that in, y is 1. X is 1, I plug that in, y is 0. And 2, -4 again. Okay, let's plot that. I don't think I need more. I've got my shape. So -2, -4, -1, 0. Zero, 1. What am I doing wrong? I've done some of these wrong. Let's see. When x is -1, y is -4. When x is -2, y is -9. So I have these off. When x is 0, y is -1. When x is 1, y is 0. When x is 2, y is -4. And when x is 3, y is -9. Okay, sorry about that. Okay, -2, -9, -1, -4, 0, -1, 1, 0, and then symmetry. Smooth curve. This is concave down. Line of symmetry is x equals 1. Vertex is at 1, 0. X-intercept, there's only one. It's at 1, 0. Y-intercept is at 0, -1. All of these I found by visual inspection. Next, I have y equals -x squared plus 4x minus 5. I'll set up my t-chart. And I think I'll start with -2. Let's see. Plug that into the equation. I get -2. Where's that cross? -2, -17. Okay, -1. -10. 0. -5. 1. -2. 2. 2. 3. Sorry, 2 is -1, not 2. -1. 3 is at -2. 4 is at -5. Then we have symmetry, ... Okay, I'll plot it. I have -2, -17. That's not going to fit on my graph. -1, -10 right here. 0, -5 right here. 1, -2 right here. 2, -1. And then we have symmetry. Okay, and I'll connect this with a smooth curve. Trying to make that look curved and not pointy. All right. A lot of this I can do with inspection. Concavity, it's concave down. The line of symmetry is at x equals 2.
Hello.
Hello. I can see that the vertex is at the point 2, -1. The x-intercepts, well, there aren't any. And the y-intercept is at 0, -5. And all of those I found by visual inspection. Okay, and 2 more. Here we go. I have y equals x squared minus 2x minus 15. And I'll start at -2. And when I plug in -2, what do I get? -7. I'm not sure if that's right. Let me check. -2 squared minus 2 times -2 minus 15. Calculator. Yeah, that's right. All right, next. -1. At -1, I'm at -15. No, that's not right. Let me try again. Sometimes it really does help to write it out. At -1, I'm at -12. At 0, I'm at -15. At 1, I'm at -16. 2, I'm at -15 again. So it seems like I've already gotten to the point where I can use symmetry. 3, I'm at -12. 2, I'm at -7. But I still need to, let's graph this and then hopefully it will be clear why you need to do more. Okay, -2, -7. Here's a point. -1, -12. There we go. 0, -15. There we go. 1, -16 right here. Again, now we have symmetry. And the reason I'm not done is because I have a parabola that opens up. I need to know, what are my x-intercepts? And since it opens up, I know that the arms will continue in this direction. But I don't know where I'm going to cross the x-axis. So I need to do, looks like at least one more point. Let's try 3. If I plug in 3, I get let me see. I made a mistake and I erased it. This one should have been 4. And at 4, I'm at -7 again. And at 5, where am I at 5? If I plug in 5 to my equation, I get 5 squared minus 2 times 5 minus 15. That's 0. Yay, I found my point. Five, 0. And because of symmetry, I can also go over 1 up to the same place. I mean, it wouldn't be, it will have the same, like, over and up from the last point on the parabola. So if I, and then on this side, I also go over 1 and up the same amount. Yeah. Okay, so those don't need to be dotted lines anymore. This parabola does, oopsie, sorry, extend through this point. All right, let's do the labeling. Concave up. Line of symmetry is at, what is this? X equals 1. Is that 1 over? Yeah, so the line of symmetry is x equals 1. The vertex is at 1, -16. The x-intercepts are at 5, 0. And -3, 0. the y-intercept is at 0, -15. And once I had my graph, I was able to do everything by visual inspection. Okay, next. Ooh, let's see. X and Y. Okay. I will start at -3. That becomes 9 minus 15 plus 1, which is -5. Then I'll do -2. -2 is also at -5. Huh. Means the vertex is somewhere between those two. Okay, -1 is at -3. 0 is at 1. 2 is at 7. Let's start graphing. Okay. -3, -5. -2, -5. -1, -3. 0, 1. And then 2 7's not going to fit. And then symmetry tells me there should also be a point here. And also here. Okay. Let's see. Now, I don't know how far down I need to go, but I do know I need to have a curve, so that has to dip. All right. Let's see what we can do here.